Hi, everyone, and welcome to Module 5 of our Programming Logic course. Now, so far in this course, you've learned how to write programs that use sequence structures, where instructions happen like one after the other. And you've also learned about decision structures where, you make a choice using if else. Now we're going to add another essential tool, which is the repetition structure, which you'll probably know by its nickname, loops. Now, loops allow us to tell the computer, do these instructions over and over again until I say stop. And believe me, loops are everywhere in the program you use probably every day. So let's dig in. So basically, the objectives for this module and specifically for this lecture are to describe repetition structures, identify different types of loops, model loops in pseudocode and flowcharts, and then implement basic loop structures in Python. Okay, so I want you to think for a moment. Now, what if you had to write code to print the numbers 1 through 100? Now, without loops, you'd literally have to write something like this: print 1, print 2, print 3, print 4, print 5, so on, all the way to print 100. And that would take forever, and it would be kind of frustrating to maintain. But instead, with a loop, you can just write like 2 or 3 lines of code and get the same result. So basically, loops, what they do is they save us time. They also reduce mistakes and they allow programs to handle large, repetitious tasks automatically. Okay, so to better understand this, let me give you a few real world analogies. So when you wash dishes, you loop through washing each item repeatedly while dirty dishes continue to exist. Okay, so as long as dirty dishes exist, you're going to keep washing. Okay, now in a classroom, say when an instructor takes attendance, for each student, the instructor will call the student's name. Okay, that's also an example of a loop. And then when you play a video game, the system is looping constantly to redraw the screen, dozens of times every second. Okay, so loops, they make repetition more efficient and more organized, both in real life and in code. Now, in programming logic, we typically talk about 3 types of loops: the while loop, which the condition is controlled; the for loop, where it uses a count to control it; and then a do while loop, which is more like a post test, and it runs at least once. Okay, so like I said, in a while loop, the condition is controlled. It's a condition controlled loop. Okay, so it repeats as long as that condition is true. So again, think of it like washing dishes. While there are dirty dishes, you're going to keep washing. So as long as there's dirty dishes, which is true, then you're going to keep washing. Now, once there's no dirty dishes, then you stop, okay? Because you're testing the condition, are there more dishes to wash? If there are, you're going to keep going, but if there aren't any more dishes to wash, then you're going to stop. So the pseudocode looks at something, like this. While conditions is true, then we're going to do something, and then in the while. Okay, so this is sort of like the flow chart for that. So the while loop starts, it tests the condition. Okay, like in our example, are there more dishes to wash? If true, then we execute the loop body. It comes back up and then it tests the condition again and just keeps looping. Once this test condition becomes false, okay, then the while loop ends. Okay, now for the for loop, like I said, it's a count controlled loop. So basically, up front, you already know exactly how many times it's going to run. So again, think of it like that attendance. For each student in the class, we're going to call their name. Okay, so we know how many students we have, and for each student, we're going to call their name. Now, for the pseudocode for this, we say for, and then we have a variable counter from 1 to 5. Okay, and we're going to count through 1 to 5, and then we're going to display the counter. And then once we reach our max, then we're going to end it. Okay. So again, here we declare our counter. We evaluate the condition. If we have, you know, um, still within our count, then we execute the statements and then we increment the counter. So we go from 1 to 2 and then we evaluate the condition. Yeah, we're still within that range. Okay, and then we keep going until we meet the last condition, which is 5. Once we meet 5, then we stop. Now, the do while is a little similar, okay, but this one guarantees that the body runs at least once. Whatever the execution code is, runs at least once. And then the condition is tested at the end. Okay, before, remember, we were testing it before we actually ran, our executed our code. With this one, we go ahead and we execute the code, and then we test it after we execute the code. Now you'll see this less often in Python, but it's really important in other languages. So basically, the pseudocode for this one is we do something and then we test the condition. While condition is true, then we keep going. So here it is. We go ahead and we execute the loop body, then we test. And if it's true, then we keep going. But at that point, once we've executed and then we test it, then we go ahead and if it's false, then we would stop. Now, again, the loop runs at least once before the condition is tested. So an example of it, do the dance move once, then repeat it until the music stops. Okay, so that means you must do the dance move at least once, okay? And then you check the condition. The condition has the music stopped, until the music stopped. Now, if the condition is true, okay, music is still playing, then you keep repeating. You do the dance move again, okay? And then you check the condition again. Has the music stopped? Okay, if it's stopped, then you go ahead. That means that you need to stop. You don't execute the dance move again. That's exactly how a do while works. It's like action first, then condition second. Now, flowcharts are a great way to visualize repetition. So here's the pattern, okay? You usually start with an initialization step. Like for instance, if we're using a counter, set the counter to maybe 0, okay, like we did here. So we assign the count or the counter, whatever the variable is, we assign it to 0. And then we use a decision diamond to ask, is the condition true? So whatever the condition is, we're asking, is it true? So in our case here, we're saying the variable count is less than 5. Okay, we're checking to see if that's true. Now, if yes, then we follow the yes or the true path, which means that we execute the action and then we loop back. So here, this is true, okay? So we go ahead and we would display I love computers, okay? And then we would increment the count, okay? And then we go in and we test it again. And as long as after we increment it, as long as it's less than 5, then we'll keep going this true or this yes path. So, we come around the first time, it's 0. We increment it, now it's 1. Okay, has it passed the test? Yes, it has. It's less than 5. So we go ahead and we take the true. Then we increment it again. It's 2 at this point. Okay, has it passed the test? Yes, and we keep going. And then once we increment it, say to 5, okay, we come here, we test it. Okay, is it less than 5? No, it's not at this point. It's equal to 5, meaning that if that this is the no. So now we follow as far as the false path, which would basically be to exit the loop. So this is how we would kind of diagram this as far as our flow chart. We have our initialize step and we have our decision diamond that's going to ask about the condition. Okay, now this looping arrow going back to the decision diamond shows basically the cycle of the repetition. Now, this visualization, when we do this, it helps us to see that loops just don't run once, okay? They can cycle many times, Okay, so again, this rectangle sets it to 0. The diamond asks, is the counter less than 5? If yes, we go this path. If no, then we exit the loop. So as you can see here, the diamond, that's going to be your key. Okay, loops are always going to revolve around a decision. Okay. Now, Python gives us two main loop structures. You've got the while loop in Python. So basically, um, this is the code, the Python code for the while loop. So this is what's happening. So we start with the counter equaling 1. Okay, we check the condition. So while counter is less than or equal to 5, okay, then if it's true, then we print the counter, okay, and then we're going to add 1 to the counter. This is our increment. This is how we increment that counter, okay? And then this code automatically is going to loop back. Okay, that's what this while is going to help us, this while loop. Okay, it's going to loop back. Now, once the counter becomes 6, okay, then the condition is false and then the loop ends. So this is all you have to write as far as when you're looping through, say, when you're printing out the 1 through 5. Okay, so instead of, having several lines of code, this is how we would do it. Okay. Now, another main loop structure in Python is the for loop. Okay, so this is the code, the Python code for the for loop. So here, what we do is for the counter, we set a range. Okay, and the range 1 comma 6 generates the numbers 1 through 5. Okay, the loop automatically assigns each number to the counter in order. Okay. And this is doing it this way. This is going to be much shorter and much cleaner. Okay, using the range function as opposed to the one in the previous slide. But they accomplish the same thing, printing 1 through 5. Now, one thing I want to warn you about, and all of us programmers have like experienced this at one time. One of the most common mistakes that a lot of beginners and us vets make sometimes, if we're not careful, is getting caught in what we call the infinite loop. Okay, so this happens when the loop condition is never false. Remember, as long as it's true, we keep looping. But as soon as it becomes false, then we're able to exit that loop. But sometimes we get caught in an infinite loop because the loop condition is never false. Okay, so for instance, if we set, looking at this code here, we're saying that we're taking the counter and we're making it equal to 1. Okay, and then we say while counter is less than or equal to 5, we're going to print counter. Okay, but the mistake is that we never do that increment. Okay, so as long as this keeps running, it's going to keep running. It's always going to equal to 1. Okay, we forgot to update the counter. Okay, so this loop is going to keep printing 1 forever because the counter never increased. Okay. All right, so this is something you want to kind of look out for. Make sure that you have some kind of exit, something that it's going to eventually be false, okay, when you get caught in these loops, okay? Now, the key rule is to always make sure something inside the loop will eventually cause the condition to become false. Okay. And that's how you kind of ward against as far as getting caught in these infinite loops. But like I said, it happens to everybody. It even happens to us vets sometimes. Now, let's look at how loops show up in real programs. So for instance, maybe we're processing a list of data. Okay. So again, going back to that student roster, for each student in the roster, maybe we want to calculate their grade. Okay. So we want to go through each student. Okay. We're looping through each student. Okay. And calculating their grade. Okay. Or maybe for each item in an online shopping cart, we want to calculate the total. Okay, so we're going through each item in the shopping cart and we're calculating what the total is going to be. That's a good use of a loop. Okay. Another one could be validating input. Okay, so we could say maybe say while the user has not entered a valid password, we're going to keep asking them. Okay, we're going to keep prompting them. Okay, and this ensures that the program, doesn't continue until the user say corrects the data. So they put in the wrong password, we're going to keep asking them. Okay, we're going to keep asking them for a password. Okay, another practical example would be like in games and simulations. While the game is not over, we want to update the screen. We want to move the characters and we want to maybe check for collisions and things like that. I want to take a moment to review our pseudocode example that we've been working together, because one of the things you're going to be doing with the assignment is writing pseudocode. And being able to write, as we talked about in previous lectures, writing pseudocode is going to be important to be able to get that logic out, when you're designing your program. So, what we want to do, remember, is we want to display the numbers 1 through 5. Okay, so for a for loop version, we would say for counter, okay, that's going to be our variable, okay, from 1 to 5. And then we're going to display the counter. And so it's going to keep looping through this until it reaches 5, and then it'll stop. It'll stop displaying the counter, okay. The other one is the while loop, okay. We set the counter to 1. We say while counter is less than or equal to 5. We want to display the counter, and then we want to add 1 to the counter and end while. See, here we didn't have to increment it because this automatically incremented it for us, in this for loop version. But this one here, we had to go ahead and we had to say that we're going to be adding 1 to our counter. So again, we don't get into that infinite loop. Now, both of these versions basically produce the same result, but the style is slightly different. So depending on what you're comfortable with, is the kind that you'll use. Like I said, neither one is wrong. You'll either both of them will do the same thing, but it also depends on, your style, what you're comfortable with as far as writing. Okay, so both of these would give us that display of 1 through 5. Okay, so in our examples, we've been displaying um, numbers 1 through 5, but this week, your assignment problem asks you to display only certain numbers within a range. Okay, so here's the process, okay, to approach it. I don't want to really give you the answer for this one, but it's going to be very similar to what we've been talking about in this particular lecture. Okay, so first thing I want you to do is basically kind of ask, what number do I want to start with? Okay, so looking at the assignment, it's going to give you specifics as far as what set of numbers within the range that you're to display. Okay, so from that problem that it gives you in the assignment or the objective, you decide what number do I want to start with. Okay, and then you want to ask what number do I want to end up with. Okay, and then the next one is, do I want all the numbers or just certain ones? Like, is it just saying you should have only the even numbers or maybe only the odd numbers, or do you want all the numbers? Okay. And then you're going to choose, like, will you do a for loop or will you do a while loop? Which one is going to make more sense here? Okay. And then the first thing you're going to do is write that pseudocode. So I've showed you how to write pseudocode when you're going through different numbers. And we'll go over this a little bit. Again, I'm going to give you some examples. Um, so you're going to write the pseudocode first. Okay. Then what I want you to do is I want you to draw out that flow chart so you can see the loops. So this is where we're going to be using, the rectangles and the diamonds and the arrows, to show how we would manipulate through that loop to display those numbers that we're asked to display. Then you're going to write and test Python code. Okay. All right. So these are the steps that you're going to use to basically kind of um, do the assignment. Okay. Okay, now I think you've got the pseudocode. Okay, again, if you need to go back through these slides and look at them, you can. I'll put some examples also in the classroom for you to be able to look at of the scenario that we've been doing, the 1 through 5. Okay, um, but um, and then the flow chart, I think you've got the flow chart, we're doing rectangles and diamonds and things like that. So I want to talk about like the Python, and you did see me kind of brush through as far as the range function, but I wanted to talk about that in a little bit more detail, because in Python, one of the best ways of, say, doing this kind of loop is using the range function. And the range function, it takes on three values. Okay, you're going to have a start, you're going to have a stop, and then you're going to have a step. So the start, that's going to be the first number. Okay, so again, like I said, once you decide what's the number you're going to start with, okay, to do the assignment, that's going to be your first number here in the range. Okay, and then what number you want to stop is going to be the number just after the last number. Okay, so if you're going to 5, okay, if you're going to 5, then 6 would be your stop number. Okay, because once it reaches 6, we know we're not supposed to print anymore because we're only supposed to print 1 through 5, right? Okay, and then the step is how much to increase by in each cycle. Okay. Um, so this third value, the step value, is really helpful like when you only want certain numbers. Like if it's telling you you're only to do the odd numbers, you need to skip numbers, okay? Because you're only to do the odd numbers or you're only to do the even numbers. So that means that you need to skip every other one, okay? Um, so I want to take a little closer look at this because, like I said, this is more like the Python. You're really not writing a lot of code in this class, but for this assignment, you are going to write this Python code, okay? And you're going to be using this range function to do it. So again, like I said, the range function is written in that range and then a parentheses, whatever the start is, whatever the stop is, and whatever the step is. Again, that first number is where the loop starts. The second number is where the loop stops. And the third number is how much it increases during each cycle. Now, here's the important part. The stop value is exclusive. Okay, that means that Python will loop up to that number, but not actually include it. Okay, so that's why in this example here, when I was showing you the example earlier, and I was saying we're looping and we're printing 1 through 5, we put a 6 here because remember that number, like I said, that stop value is exclusive. It's not going to include this number, but it's going to loop up to this number. Okay, so again, if I have this range 1 comma 6, Python's going to give me 1, 2, 3, 4, 5, but not 6. It's going to stop just before it gets there. Okay, a lot of times students get a little bit mixed up with this. So that's what I want you to remember, that it's going to stop before it's not going to print this one. It's not going to give us this one. It's going to stop here. So if you really want to see the number 6, say in my output, then what would I have to do? Change this to what? 7. Okay. So think of it like a fence post. The stop number is the fence. Okay. And the loop is going to walk right up to the fence, but never stop over it. Okay. It's never going to step over that fence. Okay. Now, like I said, the range function is going to take up to these 3 numbers. It's going to take 3 numbers, okay? Your start, your stop, and your step. But as you can see in this one, the step is going to be optional, okay? The step is going to be optional. So if you don't include it, okay, like we didn't include that third one, we didn't include the step option here, okay? Python is going to assume that the step is 1, okay? So in other words, it's just going to count one number at a time. So that's why I didn't have to include it in this because I want to go 1, 2, 3, 4, 5. Okay. Um, but if you do include the step, then you can basically change how the loop moves. Okay, so for example, in this one here, 2, 11, and 2. Okay, so the start is 2. This means it's going to start at the number 2. Okay, and then it's going to stop before 11. Okay, and it's going to count by twos. So basically the output is 2, 4, 6, 8, 10. So if you had to do like maybe even numbers, if your objective was to print out even numbers or do something at even numbers, okay, then this is how you would do it and increment it by have your step be 2. Now you can also use a negative step basically to count backwards. Okay, so like in this range here, our start is 10. Okay, our stop is 0, and we're saying take away 1. Okay, count backwards by 1. Okay, so it's going to give us a countdown 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, but remember, if you leave the step off, what Python is going to always default to 1. Okay, so this is how we're going to be doing, like in your assignment, when you're asked to print numbers, I want you to use the range function for that. Okay. Okay, so let's wrap it up, and I do want to go over a little bit of the assignment before I end this video. So um, repetition structures or loops, they allow us to repeat instructions without writing them multiple times. Okay, allows us to repeat instructions, execute, code repeatedly without writing them several times. And the two types that we really concentrated on were the while loops. Remember, that's where the condition is controlled, okay? Or the for loop, where we actually use a count to control it, okay? Now, flowcharts, remember, they use those decision diamonds to represent loops, okay? And pseudocode helps us to what? Plan before we code. So that's why it's really important that we write pseudocode so we can plan everything out before we actually code it. Now, Python gave us that easy syntax with the while and the for that I showed you. Another thing to remember is always avoid infinite loops. By what? Making sure that your loop will eventually end. You've got to have something that's going to make that condition false, okay? Or else you're going to find yourself in an infinite loop, okay? And then just remember, loops are everywhere, okay? We have them in data processing, we have them in input validation, and we see them in games. Now, this week, your practice will help you not only write loops, but also visualize them with pseudocode and with flowcharts. And then you're going to bring them to life in Python. Okay, so for this week, I want you to go in and read chapter 4 in your textbook. Okay. And that'll support this lecture as well as the work that you have to do. And then you've got an assignment where you're going to be exploring loops in Python. Okay, so for this, you're going to be using your replicate account or your trinket account. If you haven't done so, go in and create one of those. They're both um, like online editors where you can actually write Python and you would be able to export your code. And I have information in the course room about both of them as far as how you would sign up for both of them. Replicate used to be my favorite, but they got really kind of the screens got a little confusing. So I did provide kind of step by step for using replicate to get to, because it tries to force you to use a lot of AI, and we're not doing AI. So I want you to be able to write your code yourself. It's not going to be a lot of code that you're going to write. So I wrote instructions in the course room of how you would, once you get your sign up for your replicate, um, account how you would actually get to the code editors to be able to write your code. Trinket is a lot easier, a little bit more straightforward. So whichever one you use, you'll be able to follow. I also provided information on Trinket as well. Okay. And then this week, besides the assignment, you've just got like a little discussion. And the discussion is, I found this really kind of cute video. YouTube video. It's not a long video. Actually, it's one of the shorts. And I want you to watch it. And then you're going to answer like three questions about it, like what you observed, in the video. And I want you to see the connection. I want you to talk about, how it connects to programming logic. I'm not going to spoil it. So I want you to really watch the video. Like I said, I think you'll get a kick out of it. But I want you to tell me how it connects to programming logic. And then I want you to give your own example. And then for the discussion post, once you do your initial discussion post, then what I want you to do is I want you to respond to at least two of your peers, read their initial post and respond to their post. So let's talk about the assignment. Okay, so you're going to be exploring loops in Python. Okay, so I want you to practice. You're going to practice writing, modeling, and implementing repetition structures using for and while loops in Python. So excuse me, you will first review an example. Okay, so I'm going to give you an example. Okay, in the course room. And that example is going to show you pseudocode and a flowchart. Um, and then you're going to complete a similar problem. Okay, so I'm not giving you the problem, I'm giving you something like it. Okay, and then you're going to kind of use it as your guide, and you're going to create, you know, the pseudocode and the flowchart and the Python code based on the actual assignment. Okay, so first thing you're going to do is you're going to review the example problem and its pseudocode, its flowchart, and its Python code. And then you're going to complete the assigned problem by, again, creating pseudocode based on that assignment problem, a flowchart based on that assignment problem. And you can draw it by hand if you want and scan it, or you can use a tool like draw.io, which is a really very simple tool, or if you have some other kind of drawing tool that you want to use. And then you're going to create Python code that's going to actually implement the solution. Okay. So the problem, what you're going to do is you're going to write a program that displays the even numbers from 2 through 10. Okay. One number per line. Okay, so I've kind of given you some hints to that, especially for the Python code. Okay, but I want you to be able to communicate this in your pseudocode and in your flowchart as well as your Python code. Okay, so what you're going to have to do is you're going to have to write the pseudocode for your solution. You're going to have to create a simple flowchart showing the logic of your solution, and then write and test your Python code that meets the requirements. So when you use one of those editors that I mentioned, Replicate or Trinket, then you'll run it. So after you write the Python code, then you'll run the code and see if it does what it's supposed to do, which is printing even numbers from 2 through 10. Okay, that's testing it. Okay, so some of the tips for completing the code is I want you to start with the pseudocode. Okay, so this is thinking logical first, before you touch any Python. This is what we as programmers do. We have to think about what we're writing first, okay? And that's where we create that pseudocode. So few things that you're going to ask yourself is, where should the loop start? Okay, so based on the program, the problem here, where should the loop start? Okay, where should the loop end? Okay, and how much should it increase by every time? Okay, I'm not going to give you the hints, but we've talked about this. Okay, so where should it start? Where should it end? How much should it increase? Okay, this even number helps you know how much it increase. Okay, so you're going to write it out in plain English, which is that pseudocode. Okay, So an example could be for counter from whatever your start is to whatever your end is, and then display counter and then end for. Okay, so that would be like your pseudocode. Okay. The next thing you're going to do after you write your pseudocode is you're going to build your flow chart. Okay, so you're going to draw that start box, show that initialization step, like setting the counter to the first number. Okay, and then you're going to add that decision diamond that's going to check if the loop should continue. Now, if yes, then you're going to display the number and then update the counter and then loop back. Okay, showed you examples of that. But if no, then you want to exit the loop. Okay. Now, even if you draw it by hand, I want you to make sure that your arrows clearly show the repetition. Okay. So once you have the flow chart, okay, and all of this is going to be, you have to turn in pseudocode, you have to turn in flow chart. Then you're going to translate it to Python. Okay. So you're going to decide whether you're going to use a for loop or a while loop. And I showed you two examples of that, in this lecture. And either basically can solve the problem. Remember, I told you it doesn't matter which one you use, they're both going to do the same thing. Okay. The for loop, if you use the for loop, a hint might be, remember the Python's range, okay, that start, stop, step pattern. Okay, that's what you want to use. Remember that last value, the step is going to control how much the loop counts by, okay? So if I'm only doing what evens, how much am I counting by? Okay, that's my step. Okay, if you're going to be doing the file loop, a hint might be don't forget to update the counter, okay, inside the loop, or else what? You're going to create that infinite loop. Okay, then once you translate this to Python and enter it into one of the editors, then you're going to test your code, which means you're going to run the program and you're going to look to see, does it display exactly the numbers that you expect? Okay, if not, then you need to either check your starting value. Okay, maybe you're not starting at the right number. Okay, you need to check your stopping value. Maybe you're not stopping it properly. And then you need to check whether you're stepping by the right amount. Okay, so if we're incrementing it, we're not going to increment it by one, right? Because that's going to give us every number. We're looking for even numbers. Okay, so these are some of the things that you can do, if your code doesn't test out. So I have this. This is your example problem that's in the course room. Okay. Um, so this is one way of doing it. Again, you can use either the for or the while, however you want to do it. This one uses the for. So remember, this is the problem that we've been talking about throughout the lecture, displaying numbers 1 through 5, one per line. So for pseudocode, this is what we would use. Okay. For the flow chart, this is what we would use. Now, you don't see the diamond because we're not checking a condition. If you do the while, you've got to check a condition. But here, we're establishing right up front that we're only doing 1 to 5. Our counter equals 1 to 5. Okay. But again, if you want to include that diamond even in this one, you can. Okay. And then the Python code for this, we're using that range function. And remember, if we're going to 5, we've got to say 6 here. Okay, remember, we're not going to, when we're counting, we're not going to get to 6, but we need to know where that fence is. Remember, I talked about that. We need to know where we're going to be stopping. Okay. And then we're printing. So this is an example for the printing numbers 1 through 5. So you kind of take this and kind of use this as a guide and modify this based on as far as your assignment. Okay. All right. And so what you're going to deliver is you're going to have a document or a slide, whatever, with your pseudocode. Okay. You're going to have an image or a PDF or whatever with your flowcharts. I want to see your flowchart. I want to see your pseudocode. And then you're going to have either a Python file or a code snippet. That's going to actually show the Python code. I'd rather you go ahead and zip up your Python code um, and then go ahead and include that. Okay, and again, I've got instructions and everything in the course room to help you as far as creating that Python code, whether you're using either of the editors that I've mentioned. Okay. Now that's it for our lecture on repetition structure. Now, don't worry if loops feel a little tricky at first. Okay, once you kind of get the hang of them, then you'll really see how powerful they are. Okay, they're like the engine in your program. They kind of keep things running and moving and repeating. As necessary. So again, as you work through this assignment, just kind of remember, break it into smaller steps, okay? Think logically about the starting point, your ending point, and how much you want to increase each time. And then always model your solution, okay? Model your solution before you jump into code. I think I've talked about this before. A lot of programmers will start putting hand to code before they think about modeling the solution. This is why this is important in this class, is to teach you about pseudocode and pseudocode writing and flow charting, so that you can visually put it together before you actually start writing your code. Okay. So other than that, great work so far, everybody, um, and have a great week.